So this is what I will call a more efficient fireplace. So how are we going to do this? Well, there are a number of things that we can start with. Let's draw the base again of the fireplace. So there we have our base. We still have the wood, so the fuel is still in there. And just like before, we have flames. So we have some form of combustion going on. But now if we want to do this a little better, there are a number of things that we can do. And as engineers, what we can do is pull out our books and take a look at what we've learned and try to make this better. So let's begin with a number of things. The first one, what we're going to do is we're going to enclose the fireplace into a smaller area. And then what we're going to do, remember we said that there are three main components. We needed fuel, which we currently have because we have our fuel in there. We need air, and we need heat or ignition source. So let's assume that we have the ignition source and we have the fuel. We need to get air in here because it's enclosed. So what we're going to do, we're going to introduce air, but instead of just letting it flow in naturally, we're engineers, remember, we're going to put a fan and we're going to pump air into the fireplace. So the air is coming along, it's coming into the fireplace. Now, another thing we can do, why don't we try to preheat that air? So what I'm going to do is I'm going to put this vein in here, which basically separates the air. It comes in and it follows this kind of a path. It's being preheated. So through this process, what we're doing is we're preheating the air, and then we would have little jets here where the air can come in and it can supply oxygen, which is what our chemical process needs, in order for us to have combustion. So that's a good thing. We're heating the air, making it hotter. Through the process, we're actually preheating it. That makes the combustion a little more efficient. Our efficiency is going up. That's good. Now, what else can we do? Well, remember we said that before, a lot of the energy was being lost in the exhaust. So let's see how we can handle that. So what we're going to do, we're going to do something a little different here. So the exhaust gases are still coming up through here. That's where our exhaust gases are going. But now what we're going to do, let's try to get some energy out of that. Why should that energy just go out up into the atmosphere? Why don't we try to get a little more of that thermal energy and keep it within the place where we have this fireplace? So in order to do that, what we're going to do is we're going to wrap coils around the fireplace. So this could be something like copper tubing that is embedded within concrete. And what we're going to do is circulate fluid. Remember, this is a round fireplace now. we're circulating some fluid through there. So we bring the fluid in. Now if we're bringing it in, that means we're going to have to pump it at some point. So over here, what I'm going to do is introduce a pump. So from there, we have fluid that comes in, and then it works its way around. And eventually, it's getting quite hot. And if all goes well, it'll be getting close to the boiling point. Then what we're going to do, we're going to take that fluid, and we're now going to put it through the exhaust gases. So we still have our fireplace going up there. But now you can see we're taking the tube that is carrying this liquid, it could be water, and we're going to send it through the exhaust gases. So our exhaust gases are going up here. They're quite hot. And as they encounter these tubes, they're heating it. Well, we know that we can do a little better job than just that. What we can do, we can put fins on this tube. So if you've taken a course in heat transfer, you would have seen a finned tube heat exchanger. And you know what that does, it creates or increases the contact area between two fluid streams and consequently increases the energy transfer. Okay, so this is getting better. Now, so we've preheated the air, we have this liquid coming through, who knows, maybe it's water, it could be some other fluid. It's getting hotter, hotter, hotter. Then we put it through the exhaust gas. It's getting really hot. If all goes well, what we will have coming out here is going to be a mass flow rate of steam. So we now have steam coming out. And if the pump is pressurizing the liquid going in, we know that that would be high pressure steam. So what can we do with steam? We can get work out of it. So let's go over here. We're taking the steam, we bring it along. We're going to be putting it into an expander. Remember I talked about expander a couple of minutes ago. And the form of expander we're looking at is a turbine. Now what does a turbine do? Well, as the working fluid going through the turbine expands or goes to a lower pressure, we get mechanical work coming out of the device. So there, that's good, because before all we had was a fireplace where a lot of the energy was going up out the top. Now we're actually getting some work out of it. After that fluid comes out of the turbine, well, it's still quite hot, so we can do things with it. There might be multi-phase flow. You could have droplets, so you might have a flow consisting of a little bit of vapor and liquid. You're in what we refer to as the two-phase region. And if that's the case, what we want to do before we put it back into the pump, because pumps have a hard time when you put vapor through them, what we want to do is we want to condense it. So in order to do that, what we would do is we would build a heat exchanger. And what are we going to bring in? We're going to bring in some cold water. And what's coming out? Well, that could be domestic hot water. So domestic hot water would be what you use to wash your dishes. It's what you use for washing your laundry. It's what you use for taking a shower. Domestic hot water. And or, depending on how your house is built, if you have hot water heating, like I have in my home, you can use it for heating. So all of a sudden we're getting work, mechanical work, and we're getting hot water coming out of something, whereas before we just had a little bit of heat coming out of it. And then our fluid would come out of the heat exchanger and eventually it would come back to the pump. So that is a more efficient fireplace. So what are we doing and what are we getting out of this? There are three main things that we're doing. We're preheating the reactants. So that is the air is being preheated. And what we get out of it, we generate work. Which could then go into generation of electricity. And we also generate thermal energy. Okay, so we've been able to accomplish quite a bit with just modifying this, what we could consider a very inefficient fireplace. So what are the downsides to this? Well, the upsides are that we're able to generate work as well as a lot of thermal energy that we can use in our house. I guess you could say one downside is you can no longer see the flames because the entire fireplace is enclosed, unless you were to make the heat exchanger that we have here out of glass or some other transparent device where you can actually look in and see the fireplace.